If your 4x4 F-150 grinds from the front end in two-wheel drive, especially under acceleration, but quiets down once the front hubs are fully engaged, do not approve a CV axle or a front differential yet. On these trucks, lost vacuum can leave the IWE clutch partially engaged, but worn clutch teeth, hub splines, a wheel bearing, or a CV joint can sound almost identical. So, I'll show you how to confirm it's actually the IWE, how to separate a cheap vacuum leak from a damaged wheel end, and how to test each part before you buy anything. This covers the vacuum-operated IWE trucks, roughly 2006 through 2020, and the specifics vary by year, so use the workshop values for your exact truck. Note the 2021 and newer trucks use a different electric system. Is it really the IWE? An intermittent grind in 2WD, worse under acceleration, that changes or disappears when the hubs fully engage, is a recognized IWE symptom on these trucks. But it has to be confirmed, because wheel bearings, CV joints, brake components, and differentials can all make overlapping noises. Diagnosing this by the sound alone is exactly how people buy the wrong part. Vacuum on equals disengaged. Here's the mechanism, because one detail is backwards from what most people assume. IWE stands for Integrated Wheel End. It's how the truck disconnects the front wheels in 2WD to save fuel and wear, and it uses vacuum to disengage the hubs, not to lock them. In two-wheel drive, vacuum pulls the clutch away so the front wheels freewheel. Shift to four-wheel drive, the vacuum is released, and a spring pushes the clutch into engagement. So vacuum on is 2WD, vacuum off is 4WD. Hubs are not the transfer case. And this next point matters because I've seen it explained wrong everywhere. Engaging the wheel ends is not the same as shifting the transfer case into four-wheel drive. If you lose vacuum while the truck is still in 2WD, the front hubs move toward engagement, and the front axle parts can turn, but the transfer case is not commanded into 4WD. So the fail-safe here is just the wheel ends moving toward engagement. It does not mean the whole driveline dropped into four-wheel drive. So what makes the grind? Partial engagement. When vacuum is weak, the clutch ring is neither fully released nor fully seated, and under load, those clutch teeth fret and grind against each other, ratcheting and wearing. That's why it shows up in 2WD, under acceleration, and often worse in cold or wet weather. That pattern raises suspicion of the IWE. It doesn't prove it. Ford's own procedure still checks the vacuum, each actuator, the clutch rings, and the wheel bearing splines before condemning anything. Before you spend $1, learn to tell the noises apart. An IWE-type noise is an intermittent grind in 2WD tied to acceleration that changes when the hubs fully engage. A wheel bearing is a speed-related growl or hum that shifts as the truck leans through turns. A CV joint is a rhythmic click while turning, often with a torn boot. A differential or driveline issue is usually a whine tied to acceleration or coasting that doesn't change with the IWE's vacuum state. Same neighborhood, different repairs. So you test, you don't guess. Now the diagnosis, and the rule is simple. Cheapest test first, not cheapest part first. Cheapest part first is still guessing. Start by confirming your exact year and 4x4 system, then reproduce the noise safely. Inspect the vacuum hoses first. They run down each side of the frame and get brittle, cracked, pinched, or water contaminated over the years. Then check the one-way check valve for correct direction and operation. It's an early item in Ford's procedure because it's cheap and critical to holding vacuum, though that doesn't make it the culprit on every truck. Test the whole circuit. For the trucks covered by Ford's procedure, connect a hand vacuum pump to the IWE supply line and apply about 20 inches of vacuum. A healthy circuit holds it, dropping no more than about ½ an inch per minute. If it leaks, you move inward. Apply that same 20 inches to each IWE actuator individually. If one wheel end won't hold vacuum, that actuator is leaking. Inspect or replace it. If both hold but the circuit leaked, the problem is upstream. The lines, the reservoir, or the solenoid. Then command the solenoid with a scan tool, engine warm, and confirm it's actually delivering vacuum. If it isn't, you test the solenoid, check valve, reservoir, and supply lines to find which. Not replace. Test. Vacuum passes, noise remains. Here's the part that changes the whole repair. If the vacuum holds everywhere but the grinding is still there, the damage is already done. Prolonged partial engagement wears the clutch teeth and the wheel hub splines, and once those are chewed up, fixing the vacuum leak restores the vacuum but not the silence. So, Check the hub splines and clutch rings before you ever look at the axle or differential. This is why nobody should promise replace the valve and the grind is gone. A cheap leak can start the problem, but it doesn't guarantee the repair is still cheap. And only after all of that, if the vacuum and wheel ends check out, do you move on to rule out the wheel bearing, the CV joint, and the front differential. Repair only the section that actually failed a test. A few important specifics. On the cold start behavior, don't mistake it for a fault. On these trucks, the transfer case module keeps the hubs engaged at startup for a set distance, about half a mile when it's above freezing, and about 2 miles when it's below freezing, once per key cycle, to delay vacuum use until the engine builds enough of it. So a little startup engagement is normal and programmed. Grinding, ratcheting, or a failure to disengage after that distance is up is what needs diagnosis. And critically, the engine needs to run about 5 minutes to build enough vacuum before any vacuum test is valid, or your readings will lie to you. On the solenoid, its known weakness is water intrusion because it sits low under the hood. Later trucks added a shield, and Ford eventually relocated it. So find yours on the vacuum diagram for your truck, rather than assuming, and if you replace it, use the VIN-correct part. On certain 2017 to 2018 F-150s, Ford also released a TCCM software update that changes this startup strategy, so check your VIN and build date against current Ford service information before assuming you need it. If you get to the IWE actuators themselves, respect the job. Reaching them means brake, hub, axle, and suspension disassembly, and the exact steps vary by year. Follow the workshop manual, torque to spec, and replace any one-time use fasteners Ford specifies. And the safety non-negotiables: support the truck on rated stands, never a jack alone, never let the brake caliper hang by its hose, and don't attempt suspension separation without the right tools. If that's beyond your setup, hand this stage to a shop. You'll also hear about deleting the system for manual locking hubs. It's not a universal cure. Compatibility varies by axle and year. Some kits keep the hubs engaged all the time, while others require you to lock them by hand. And it can change fuel economy, wear, noise, and your fail-safe behavior. If you're considering it, verify compatibility, legality, and warranty impact first. For most owners, repairing the vacuum side is simpler. So here's the whole thing. Confirm the noise pattern, inspect the hoses, test the complete circuit, then each wheel end. Command the solenoid. If vacuum passes but the grind remains, inspect the clutch rings and hub splines before you ever blame the axle or differential. And whether you do this yourself or pay a shop, make sure the vacuum and wheel end tests are actually done and documented before anyone quotes you expensive parts. Because front-end noises overlap, and the test results are what separate a cheap leak from a damaged wheel end. If you want to know which F-150 years and setups give the least trouble in the first place, that's next. The best and worst years to buy. I'll see you there.